Yeah. I don't know
All
why
right.
we don't do that anymore.
I know, right?
Yeah.
All right. Welcome, everyone. Live and direct, Fault Proofs. We are here to talk to you about the overview. We got a all-star roster. We got Kelvin, Benevolent Chaos Monkey, co-founder of Optimism, famed Ethereum dev, and the originator that made everyone realize that rollups aren't real.
Right.
Then we got Tame, shining ray of light from Sunnyside Labs, aka Test and Prod, builder of spam batches, lowering fees massively, OP Aragon, and much more. And then we got Annika, we got Day Zero on base, working on smart contract engineering and product. Let us get going. So, y'all, welcome.
Yeah.
Okay. Well, today is a crazy day. Why is it crazy? Fault proofs have shipped. But then the question becomes, what are fault proofs?
What are fault proofs?
Kelvin.
I don't know what a fault proof is. What are fault proofs? Well, fault proofs are a way that we can sort of prove to Ethereum what happened on an OP stack chain, or what's going on an OP stack chain, without running the whole thing on Ethereum. Because that's kind of the whole point of scaling, is that we want to move computation off of Ethereum. And fault proofs are, a little different than ZK proofs, where ZK proofs are explicit mathematical proofs about some thing, some computation, some blockchain, whatever. Fault proofs are a little different. Fault proofs, instead of being explicit proofs in a lot of ways, are these kind of implicit proofs, where somebody can say what they think happened on, the OP stack chain, and then somebody else can come in within a certain amount of time and challenge that original person. And people can go back and forth and basically determine who's right. Was the original person right or not? That's a very high level, very simple way of looking at fault proofs. And fault proofs are really important because they let you communicate that state the way that the layer 2 looks, what's been going on the layer 2 to the layer 1, which is a key thing if, for example, you want to prove that you made a withdrawal on the layer 2 and you want to get some ETH or some ERC20 tokens out of the bridge. You need to be able to prove that to the bridge on layer 1, and that's what a fault proof gives you in this case. Yeah.
So we're able to prove withdrawals on layer 1 without intervention, I guess.
Without intervention, yeah. So that's another big piece about this fault proof release in particular, is that this fault proof is not permissioned. There's no specific role that says, that is allowed to play the game. Anybody can claim what the state of the layer 2 is. Anyone can say, here's what's been going on Optimism, or on OP mainnet. Here's what's been going on Base. It's not live on Base yet, but we'll get there. And then later on, based on that claim, you can then go and execute, a withdrawal. And similarly, just like anyone can create a claim, anyone can challenge a claim, which is a big deal, because it's the first time that one of these general purpose fault proofs has gone live in production on mainnet, where anyone can create a claim and anyone can challenge a claim. So pretty cool stuff.
Wow, I'm getting hyped listening to this, but I'm curious, why are y'all excited about this fault-proof release? Tam or Annika, y'all go for it.
Yeah, I mean, we've been super excited about the idea of decentralization and just removing any trust or kind of centralization assumptions. And I think one thing I would add to the description is that I think is really cool about the way the system is designed is as long as there's one honest challenger, the system still functions. So there could be like a whole series of malicious actors, and you just need like one honest participant. So I'm pretty excited about that specific detail, and also to see how we can continue adding more layers of this sort of thing to the OP stack.
Yeah, one thing I want to add that's I think important for people is that I think a lot of the times when we hear the word honest, we assume like altruistic or just doing it, like spending money just for the sake of spending money. In this case, it's important we use the word honest in this very like protocol-y way, but the fault proof basically rewards you for being correct. So you do have to play by the rules to get rewarded, and we call that being honest. But if you do that, you get rewarded, and you get rewarded more than what you're spending to be able to play the game in the first place, which is a big deal because it means that people out there have a real ETH incentive to participate in this process. And we're not relying on altruism in the OP stack.
So I also heard, by the way, that it wasn't just fault proofs were shipped, but there's this thing called stage 1.
Yeah.
What does that mean, and why is that important?
Stage 1, my God. Well, stage 1 is fundamentally about getting rid of certain parts of the trust model and getting closer to stage 2, where we really remove a bunch of these safety nets and things like that in the system. So a big part of stage 1 was making it, of course, we needed the fault proof. That's a big part of stage 1. But also, alongside the fault proofs upgrade, there were a bunch of smaller little changes that were made to take the security properties and things that we were relying, or the system itself, the stack was relying on the foundation, let's say by itself, and taking that control and putting it also into the hands of the Security Council. It's this group of, 12 signers. 12 signers, independent signers, people who are not related to the foundation. So it's already a more decentralized set of people, a more robust set of participants. And at this point, I think it's the case that there basically is no single way that the foundation by itself could upgrade the system by itself, could cause a permanent halt of the system by itself. Essentially in all these cases, the Security Council can maintain the liveness of the system on its own. And all of the upgrades that you could do have to be in tandem with that Security Council, which is that's a big shift to the security model, where we're not, the foundation now does not have this ability to upgrade without, or actually they did not have this ability to upgrade without the Security Council, but to cause certain types of halts to the system without the Security Council. It's a big deal.
Crazy. And we're also working on getting to stage 2 with things like Asterisk Tame. What's the TLDR there? I'm curious.
Yeah, what is stage 2?
Yeah, what is stage 2?
Why is stage 2 important? What's the deal?
Stage 2.
What are you doing?
Stage 1 implies there might be a 2, right?
Right.
Yeah, that's true. And that's one of the reasons why I am super excited about the stage 1, because we are finally here, but it's only the start. It's only the start. There's a long way to go. So stage 2 is a status whereas the rollups are autonomously being maintained. For example, no central actors can push the code themselves, and it's not upgradable, just the Web 2 components or those kind of things. So the protocol upgrades is being pushed by multiple consensus, and the also the everyone can challenge and the the rollups is being maintained by decentralized governments itself. So the asterisk is that is a fault-proof is a fault-proof VM that runs the RISC-V. Current fault-proof VM is Canon, which runs the MIPS. So we are adding one more VM, which is on RISC-V. So so at the end of the day, what we can do is that we can aggregate those we can combine those proofs into one and make a result that if the state is valid or not, which means the protocol can at certain states the protocol can choose what's right and wrong at the end of the day without the human's intervention. So yeah, I'm very excited about the what we've done so far, and I'm really excited to push more codes into the future. Onwards, let's go.
Nice. Yes, and Tame is very humble, and in case it wasn't clear, Sunnyside has been, while stage 1 has been in under development. Now that OP mainnet is on stage 1, we'll talk about the base thing. But at the same time, Sunnyside has been shipping Asterisk, getting it into production, an alternative VM, and so y'all will. I'm sure we'll hear more updates on that soon, but it's very exciting to see that coming. And then, okay, we've hinted at it twice. I'm curious, obviously we're trying to get everyone in the super chain to stage 1. Annika, do you want to talk about Base and its roadmap to stage 1?
Yeah, definitely. So we're just as excited to get to stage 1. Been trying to tease out all the dependencies and just all the work we need to do to get there, but feeling pretty on track to hopefully get to testnet in July sometime. And we just today actually executed the final pre-upgrade needed to get there, and have a lot of people working hard on it. So after that, we'll do sufficient testing before we get to mainnet, but we are super hyped to get there.
Nice. Yes, this is the power of decentralized development and the super chain coming into action, firing on all cylinders. Okay, so hidden stage 1. Honestly, I'm curious. Yeah, Kelvin, you've been working on fault proofs for quite some time. How did we get here? What's a little TLDR
of the history of
the history? Because we
yeah.
started at what is fault proof stage 1. This is great. I'm just curious, a little background context.
A little lore. Well, wow. Optimism has had an interesting history with fault proofs. It's been quite a ride, I would say. I think that as an ecosystem, Ethereum has learned a lot about how to build rollups and how to build fault proofs, and I think here at Labs we've also learned a lot about how to just build stuff in general, and so we've kind of it was a bit of a twisty turny path, I guess, to get here. Early on, back in the day, when I first started working on Optimism stuff, we were, which is a beautiful piece of software. And now the OVM, the whole thing behind the OVM was we're gonna re-execute all. In the case of a fault proof, we're gonna re-execute the whole transaction on layer 1, and that's very different from the way that we do things today. Where we don't re-execute an entire transaction, we re-execute a very, 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 very small bit of a transaction that we disagree on. But back in the day, we were talking about we're going to re-execute a whole transaction. Now, re-executing a whole transaction is a bit of a mess for a number of reasons. But one of the biggest ones is that let's say you have an opcode like block.timestamp, the timestamp opcode that gives you the current timestamp. When I executed that opcode on layer 2, it had some value. But if I go and I re-execute that same opcode on layer 1, sometime later, it's going to have a completely different value. So we can't have that because we needed the execution to be exactly the same. So we banned people from using that opcode. Now, banning people from using an opcode is not easy. Not easy at all. And it was a whole mess. We did a lot of work. We had this crazy thing where we had to take Solidity and compile it into our own version of bytecode that would go and do all these crazy things, and we call it the OVM. And it would take us forever to do anything. And there were certain projects where it would take our team and it would take their team, and it would take 2 months to deploy a smart contract. That doesn't work. So we tried this. We were in the arena trying things, and we decided that it didn't work. So I guess about 3 years ago, we decided to throw it out. Yeah, almost exactly 3 years ago, we said we're done with this, and we're going to throw it out. And so we made that decision. We decided to toss all of it and introduce this idea called EVM equivalence, which was a novel concept at the time. That was something that we just decided we should do, and we did it. And we threw everything out. We tossed the whole thing. It was tens of thousands of lines of code that we just completely tore out. Yeah. And what?
Start over.
Oh yeah, we started the whole thing over.
Yeah.
But with a lot of learnings, with a lot of new knowledge. And after that, we started this thing called Bedrock. So actually, took us about 5 months. We tore out all the old code. We basically launched the system for the second time with all the old stuff torn out, and then we started this thing called Bedrock that was going to enable us to build this new type of system with a very modular, pluggable, fault-proof that would be far less limited. Taking on some of the learnings of plenty of other people in the space. About how to build these systems the right way, and building, the whole thing from scratch, but importantly, from scratch in a way that allows us to reach the real end goal of security, which is stage 2, by making it possible for us to have multiple client implementations, right, to prevent bugs in any one client, and multiple proof implementations to prevent bugs in any one proof. And we can mix and match these things so that, if you have a bug in any one system, you're not out of luck, So this has been a very long project with so many things that we learned over literally years about how to think about writing software, how to think about, especially in these systems that are, so many people rely on, where you rarely get second chances. We were really lucky to get a big second chance, and then it became clear that we might not get that again. So let's do it the right way.
Yes, and we started out really wanting to ship a optimistic roll-up end-to-end, fully finished, just get it out the door. We were like, okay, we got the whole thing. And we were so interested in reaching that end state that we just cut a bunch of corners. We just took a bunch of shortcuts, made it. And what we have since learned is a couple things. It's one, that slow is smooth and smooth is fast, right? We need to take our time to ship things correctly. We learned about minimal diff. We learned how code complexity can pile up really fast. And we learned that you really have to think about how to solve a problem first. Just think. Spend 7 hours thinking, and then just 1 hour implementing. That is, you should have the design ready and execute. And I think the final learning that we really had was that we're not building a product in the traditional Web 2 sense. We are building an open source ecosystem. We're building standards for the entire community, the open source community, the Ethereum community, Web3 community. And that means that these principles that I was talking about before are extra important, because in order to build something that other people want to build on top of, you need to have the foundations be rock solid. You need the modularity. And so, okay, I mean, I talk about this all the time, but I normally don't have Tame here to back me up. But how was it building out Asterisk in the stack versus having to how fitting that piece in? How was that experience? I'm curious.
It was amazing.
Hopefully, well, I mean, if you tell me it's bad, then never mind. No, just kidding.
No, Carl, everything was amazing, I would say. Yeah, because Asterisk is Sunnyside's, soon to be Sunnyside's currently testing prod. Testing prod's third project. The first one is OP Aragon, the second one was building spam batches and Delta, and the third one was the Asterisk, and we're still building that. The experience was amazing because of the two things. The first, the spec was so well designed. So as you just said, after so as Kelvin and Carl just said, after y'all built the OVM, we started to build Bedrock with the name of the Ethereum equivalence. And at the Bedrock, we just could see the spec is very, very well written and very, very well thought, I would say. It's just like inheriting Ethereum as much as you can, and the spec is very, very simple. So we really didn't have much problem, fitting our codes into the system. Just all we have to do is just taking time to read the codes and taking time to read the specs. Very, very well written specs. So we didn't have any problems with the spec. So spec was well thought spec was the first thing. And second, the support from the OP Labs and the Optimism Foundation was amazing. Not just about the support, it's just people was amazing. They're really, really good to work with. There are tons of supports, and I've talked about this in last year's 2 year space, but at the down of the Sunnyside Labs contributing to the Optimism stack, we just slid into the Kelvin's DM and saying that, hey, we wrote this thing and we wrote this blog and we understand this. Is there anything we can do? And Kelvin was very, very helpful about it. Just after a few days, Kelvin and the Labs folks discussed about the project and defined it, and why don't you build this? And that was the starting point of Aragon. And for Asterisk as well, it's very, very the Labs was very, very helpful and transferred a lot of knowledges to build this stack successfully. And very welcoming, good vibes, perfect people. Thanks, Carl. Thanks, Kelvin. Thanks, everyone in the Labs and foundations. Yeah. So, people, well-written facts, go Optimism.
Oh my gosh. Wow. Well, yes.
Yeah, how do you beat that?
How do you beat that?
I don't know.
And shout out Base. Y'all are shipping all these features for the upcoming Fjord hard fork. Incredibly exciting. This is a genuine team effort.
It's crazy.
It's crazy.
It's really just selling me. I don't know. I've looked at crypto for so long. We've been, always the selling point of crypto. I don't know. It depends on maybe how long you've been in crypto, but back in the day, everyone was like, "Oh, it's Ethereum is a platform for coordination and this and that and this and that," and like now it's kind of actually happening, and it. I mean, how many client teams, how many clients, how many different proof systems being built, then teams building like mainline features in hard forks, and it's like it's just happening. It's just the beginning of it. It's crazy.
The acceleration, like it's literally like we're in a Tesla right now. You know what I mean? It is insane, and it really is so much bigger than any individual person, organization. Like it is aligned incentives, and that is an open source software. Like, I don't know, I feel incredibly grateful to be in this room. Okay, sorry. Speaking of other folks, we've got some questions from y'all. I will read the first one, although maybe there's only one. There's lots of questions out here. Can you elaborate on how the fault-proof system allows users to trigger withdrawals from L2 to L1 without the need for a trusted third party? Thanks, team.
Yeah.
Anyone?
Well, I've done this spiel before, so I can explain it. All right. So here's how this works. When you do a withdrawal, what's happening in that process is that you are proving to the bridge on layer 1 that you had some ETH or some ERC20 tokens on layer 2 and you got rid of them. You burned it, right? So to prove that, you need to be able to show to the layer 1 something about the state, the insides of the layer 2. But the layer 1 needs to have something for you to prove against. And that thing we call a claim about the layer 2. We say, this is what the layer 2 looks like at this current time, right? This is what OP mainnet looks like. This is what Base looks like. And using that little claim, you can prove that a withdrawal, that you actually burned those tokens on the layer 2. The thing is, that claim is just that. It's just a claim. It's just a statement that you're making about the layer 2. The question is, how do you prove it? How do you prove that that statement is actually true? Because the whole point, like we said before, is that you don't execute the layer 2 on layer 1 because that's not scaling. You're supposed to do the execution somewhere else. If you just executed the whole thing, then you're not scaling anything. So we don't execute the layer 2 on the layer 1. So how do you prove it? So before fault proofs, what we had a role called the proposer, and the proposer submitted these claims. And then there was a period of time, 7 days, where the guardian, right, this other role, this trusted role, was expected to be watching what the proposer does and invalidating anything that the proposer puts out there that's not correct. If the proposer puts something incorrect, get rid of it. And so in that universe, you are trusting that person, that watcher, to keep the system safe. And you need the proposer to be constantly submitting these proposals. If the proposer stops submitting the proposals, you're not withdrawing. And if that watcher is not watching, the proposer could do whatever they want. So fault proofs changes that specific part of the withdrawal process, where instead of there being one proposer, anyone can propose whatever they want. Anyone can submit these proposals as to what they think the layer 2 looks like. And instead of there being one watcher, anyone can come in and challenge those proposals that those other people have made, right? So that's how you get rid of these roles, the trusted proposer and this trusted challenger. So now you don't need these things to be sitting there to be able to trigger these withdrawals. I will say an important thing to keep in mind about the security model today and why this is stage 1 and not stage 2 is that there is still a security council, right, with the thing that we talked about before, that acts as a safety net, right? There's a period of time after these proposals get made where they just kind of sit there and they can't yet be used to trigger withdrawals. And the Security Council can keep a watchful eye on things. And if there's an error, if there's an issue in this process, the Security Council can prevent a proposal from being used for withdrawals. So the Security Council still sits there as a security mechanism, but it's much different because you don't need this active watching role that goes and keeps an eye constantly and makes sure that the proposer isn't submitting bad things all the time. It can take a much more passive role. It doesn't have to be actively, it doesn't have to have more active access to private keys, things like that. It can take a much more passive role and let the proof system take care of itself unless there's a really, a specific critical bug that needs to be addressed.
All right. Well, now you know how fault proofs work. Why don't we get some closing thoughts? Annika, do you want to kick us off?
Yeah, just super glad that OP has gotten to stage 1. Congratulations to y'all, and thank you for setting the stage for us to get there. And thanks for having me on the call as well.
One super team, one super dream. Very exciting.
All right.
Tame, Kelvin?
Oh yeah. First of all, thanks for having me. It was a great talk. Super excited to build this up with y'all, and super excited for the stage 1 finally. Long way to go onwards.
Let's do it.
Let's do it. Ship it.
Stage 2 robust.
Thanks, y'all.
Robust. Yes. All right.